Hello and welcome to SudoKanard. As you may hear from my bassist voice, I've had a sore throat in recent times, and this is why I interrupted my series of videos on the birthday puzzles that were requested by my friends Fabien and requested from very famous and great authors from all around the world. And the author of this very puzzle is none other than Tiit Vunk from Estonia, who is the reigning world Sudoku champion. And the puzzle that he has made uses the variant odd even Rossini that was featured in the recent World Sudoku Championship. And it was a puzzle that I couldn't solve during the contest. I attempted it and I wasted a lot of time. So the special rule of Rossini is that whenever you see such an arrow, it means that the three digits here are ascending in the direction of the arrow. So this is smaller than that, which is smaller than that. It acts like a thermometer, to quote some other classic variant. So here the digits are ascending in this direction, and all arrows have been given, which means that here the digits can't be ascending this way nor that way. You may be surprised to see a zero here, but for some reason Tiit decided to write 50 in some places of this grid. Your guess is as good as mine. So we will have to use digits from 0 to 8 and not from 1 to 9, which is another difficulty. And you will have noticed those blue, white, and red French flags, which are a very nice addition to the puzzle. So what do they mean? Blue means, it means even. Those are even digits, ascending even digits here. Red mean odd digits, so ascending odd digits here, and white means both of them. So here we must have at least one odd digit and one even digit. And if there is no arrow, then there's no color. So we don't know the parity of any of those digits. So that's it. Let's start with this puzzle. So I've already solved it, but it was quite a few days ago, a few weeks ago, to be honest. And let's remember that because the digits are from 0 to 8, odd digits are more constrained than even digits. We only have 1, 3, 5, and 7 as odd digits. We don't have the 9. And I'm pencil marking those in this way because they are ascending. The same happens here. And the same happens here. And we can already see, can we? No, not yet. Let's pencil mark the even digits as well. So they are ascending, but they are from 0 to 4, 6, and 8. So the pencil marking goes this way. So 0 to 4, 2, 4, 6, 4, 6, and 8. But here we must be ascending. So the only way to have this digit smaller than this one and to have something between them is to put a 4 here and a 7 there. So that's a 2 and that's a 0. So that's not a 4, that's not a 2. So this can't be a 4 to keep this ascending. Now those digits here are ascending as well. So 8 has to be here, 6 has to be here, and this can only be a 5 to be comprised between those two digits. So that's a 3 and that's a 1. This 6 puts a 4 there, this 3 puts a 5 there, and that's a 7. And I think that's it for the time being. So you can see that those digits are indeed not ascending, even if we didn't quite use the negative rule. And here this is ascending, so this must be bigger than 5. 6 is not available, 7 is not available, so that's an 8. And we are left with 0, 1, and 7. So this is 0 or 1. But considering this is ascending, this has to be the 1. And that's a 0. And that's a 3. So that's a 2. And we have a 0 and a 7 in here. Oh, and this 8 gives a 6 in here. And this 6 in turn puts a 6 in here. We have a 2 and a 4 there. And both options seem to be possible at this point. If I try to put 8 on either side of the 7, then the 3 digits will be in ascending order. So 8 won't be here, and because of this 8 will be here, and that's a 1. And here we have a 5, it's here because of the given 5, and that's a 3. We can check that no arrow had to be given here indeed. So no arrows here are to be given either. And something interesting here is that 3, 5, and 7 are not here. They're not here either. So they must be here. And they must be here. That is called roping. And this digit... why did I put a 6 here? That's a 7. So I was saying this digit must appear somewhere in here, but 0 must be there. No, 0 must not be there. So this is 2 or 4. That's the counterpart of this. And the other 2 digits are 6 and 8. So here I must have the 0 and the 1 and the 2 or 4. Nice. So here this is 2, 4, 6, 8. This is some heavy pencil marking. 8 will not be good in this position because of this. And here we must have digits from 0, 1, 2, and 4. And that's not a 0. Here all options seem to be possibilities. This can still be ascending, and here I don't think there's any more constraint on that. But I'm seeing the zeros there, and they place a 0 into this cell. I'm also seeing the 5. They place a 5 here. We are left with 1, 3, 7, 8. 3 and 8 must be removed from that, so no arrow here. That's a Saturday. Oh, we will use the negative rule. 4 here would require an arrow there, so that's a 2. So there's a 4 here, we can remove it from there. That's the 4, that's the 2. And that's the 4. Alright, so this match is good. Because of the zeros here, we must have a 0 somewhere there. But to keep things ascending, this is never a 0. That's the 0. This not 0, that's not 4, that's a 0. So this digit must be bigger than this one, because there's no arrow here, and the same is true here. This digit is bigger than this one. Now with the 5s I can put a 5 in here and there, so this is ascending. 0, 2, 4, this must be from 1 and 3, and this is from 2, 3, 4. Well, 0 is not that much information to state that this is ascending. This column still needs 2, 4, 6, and 8. That's not 2 or 8, that's not a 6, that's not a 4. And if I recall correctly, this is the part where the puzzle becomes really, really tricky. Now let's notice that this is not 1 or 7, so it can only be 4 or 6, and that's the other 1 or 7. So now we have very little to work with. Oh, not that little. 3 here wouldn't work because this would have, if this were 1, 3, and 5, this would have to be red. So this must be an even digit, so that's not a 3. So this 7 is interesting. It must appear somewhere in there. And this one must appear somewhere in here. And now this is really a question. Where should I look? So one of them is a 7, comes with an 8 in here. The other comes with, oh, this is ascending, so this can't be a 6, that's a 4. So the 3 comes with the 6, so the 7 comes with the 8, and the 3 comes with the 6. I'm really not seeing what happens. 7 and 8. 7 and 8 here would be interesting. They would put 7 and 8 right here. Would it be impossible? I don't see why it would. It would have, but something else I'm seeing. 3 and 8. It can only be here in this region. And in both cases, the negative rule here is satisfied. But now, here, this is 2 or 4, this is 2 or 6. That's a serious restriction. And there's a 2 in here, so we must have a 2 in one of 2 places there. And they are actually from 2, 4, and 6. And here there's a multitude of options for all those digits. So is there anything interesting about those? We know that they must not be ascending. So if I make this a 1, then this won't be a 2, this will be 4 and 2, in which case those are 7 and 9. Right? So let's keep in mind 7 and 9. I just pencil mark them here to say that in this case those are 7 and 9. But if this is 7, we know that one of them is a 2. It can't be here because then this would be ascending. So the 2 would be here with the 6 there, in which case those would be 4 and 7. And 4 would be 4 and 9, sorry. In which case 4 would be here and 9 would be there. So this can only be 7 or 9, and this can be 4, 7, or 9. I must have been missing something. So let's start again. If this is 1, then this is 2, and this is 4. Oh, I said 7 and 9. I meant 6 and 7. All right, I was wrong. So in the first case, that's 6 and 7. In the second case, this is 7. That's the 2 and that's the 6. Then those are 1 and 4. So 6, 7 or 1, 4. So this here is from 1, 6, and 7. And I just pencil marked the 4 options, which is just saying that 2 is in here. So that was completely useless, I'm afraid. So is there anything interesting to say about this? I'm really not sure about that. Note that if 8 is here, then the negative rule here is satisfied, but to satisfy the negative rule, 1 must be here. In which case, this is a 3, and that can't be a 2, so that's 6, 4, 2, 7 and 3. Just trying to see if something breaks, but that's completely fine with a 6 here. 1, 7 and 8 here. So I see no issue with that, but the interesting part is that 8 here makes those 4, no, 2 and 4. So 8, 2 and 4. If I try to put 8 here, and that's 8, I get the 1 and the 3 here. The 7 must be there. That's 1 and 3. So this is from 2 and 4. And nothing seems to be broken in this case. I'm looking to see if I can find some measure of elimination. Oh, there's some measure of elimination. 4 has to be here. On this row, yes, on this row, in this box, 4 has to be here. So that's a 2, and that's a 1. Oh, this is definitely something I've been missing. So that's not 1, that's not 2, that's not 1. And in this box, the 2 is here. So that's a 1, that's a 2. There's no 1 in here. That's in this box, the 1 is in here. So that's a 7. And that's a 1. Here we get the triple. Alright, so this is progress. So 3, 6, 7, 8, 6, 8. So this is from 3 and 7. This is from 6, 7, 8. And because of this one, that's a 1 here. So 3, 6, 7, and 8 in there. So that's 3, 6, or 8. That's 3, 7, or 8. This column still needs a 3, 4, and 7. So is there... Oh, that's the one. So I had studied what happened with 1 here. 2 can't be there, so 2 has to be here, and that's a 4. So 6, 4, 4 here, not 4 here, but 4 there. Right, so what next? So this is smaller than that, and there's no arrow, so this must be bigger than 4. So the 3 must be here. And that's a 7. And because of this 7, I can't have an 8 in here. But anyway, yes, there's a 3-8 pair, so that must be the 2. But the interesting part is that this can't be ascending, so that has to be a 3. That's 8 here, 3 there. So this 3 puts an 8 there, a 3 in here. That's 7, that's 3. And because this is not ascending, that has to be 8, and that's a 6. And then, so this is from 6, 7, 8, and there's still something to be done. And I'm just not seeing it. Oh, that's the 7 here. So 6 here, 7 there. That's a 6, that's 8, that's 7, 8 and 6. So that was really a beautiful puzzle. I just struggled for no reason. Well, I struggled before I had failed to see the restrictions on digit 4 in some places, that's all. So very nice puzzle by Tiit Vunk with lots of Easter eggs, and I'm really thankful for this present, and a huge thanks to Fabien, who was at the root of all this big project. Thanks for watching this video, and see you soon on SudoKanard.